Master of Architecture. MH4201. Sustainable Architecture, Historic and Community Perspective. Subject Concept Outline and Short Notes. Unit 3 and 4. Traditional Architecture and its Response to Climate. Traditional architecture has always been responsive to climate, as it seeks to create comfortable living spaces for people while minimizing the impact of the external environment. Here are some examples of how traditional architecture has responded to climate. Passive cooling. Traditional buildings in hot and arid regions are designed to promote passive cooling, using techniques such as courtyards, wind towers, and thick walls. These elements help to create natural ventilation and shade, reducing the need for mechanical cooling systems. Thermal mass. Traditional buildings in cold regions often incorporate thermal mass, such as thick walls made of stone or adobe. This helps to regulate indoor temperatures by storing heat during the day and releasing it slowly at night. Orientation. Traditional buildings are often oriented to take advantage of the sun's path and prevailing winds. For example, in hot regions, buildings may be oriented to face north-south to minimize solar heat gain, while in cold regions, buildings may be oriented to face south to maximize solar gain. Natural materials. Traditional buildings are often constructed using locally sourced, natural materials such as mud, stone, and timber. These materials have high thermal mass and provide good insulation, helping to regulate indoor temperatures. Water management. Traditional architecture often incorporates water management strategies, such as rainwater harvesting, to cope with drought and water scarcity. In some regions, buildings are designed to channel rainwater into cisterns for later use. Overall, traditional architecture has developed over centuries in response to the local climate and environmental conditions. By incorporating passive design strategies and natural materials, traditional buildings have demonstrated a sustainable and climate-responsive approach to architecture. Traditional architecture and its response to climate. Sustainable architecture in human settlement planning and housing. Sustainable architecture in human settlement planning and housing involves designing and constructing buildings and communities in ways that minimize their impact on the environment and promote social and economic sustainability. Here are some key aspects of sustainable architecture in human settlement planning and housing. Energy efficiency. Sustainable architecture aims to reduce energy consumption by designing buildings that use less energy for heating, cooling, and lighting. This can be achieved through passive design strategies such as natural ventilation, solar shading, and energy-efficient building materials. Water conservation. Sustainable architecture also focuses on water conservation by using technologies such as rainwater harvesting, gray water recycling, and efficient irrigation systems. Sustainable materials. Sustainable architecture promotes the use of eco-friendly building materials, such as bamboo, straw bales, and recycled materials that are renewable and have a lower carbon footprint than traditional building materials. Community development. Sustainable architecture in human settlement planning also involves creating communities that promote social sustainability. This can be achieved by providing access to public transportation, creating public spaces, and encouraging community participation in decision-making processes. Affordable housing. Sustainable architecture also promotes affordable housing by designing buildings that are energy efficient and require lower maintenance costs over time. This can help to reduce the financial burden on low-income households and promote social equity. Overall, sustainable architecture in human settlement planning and housing is about creating buildings and communities that are resilient, eco-friendly, and socially and economically sustainable. By integrating sustainable design principles and strategies, architects and planners can help to create a more sustainable future for all. Examples from vernacular and planned cities in different geoclimatic zones. Here are some examples of sustainable architecture in human settlement planning and housing from different geoclimatic zones. Vernacular architecture in hot and dry climates. In hot and dry regions, vernacular architecture uses passive cooling techniques such as courtyards, wind towers, and thick walls to provide natural cooling and ventilation. An example of this is the traditional mud brick houses in the city of Yazd, Iran, which use a combination of thick walls, shaded courtyards, and wind towers to keep the interior cool. Vernacular architecture in hot and humid climates. In hot and humid regions, vernacular architecture uses raised floors, elevated roofs, and natural ventilation to keep the interior cool and dry. An example of this is the stilt houses in the Mekong Delta region of Vietnam, which are built on stilts to keep them above floodwaters and use natural ventilation to keep the interior cool. Planned cities in cold climates. In cold regions, planned cities such as Stockholm, Sweden, use district heating systems that provide heat to entire neighborhoods from a centralized source. This reduces energy consumption and carbon emissions, as well as promoting social and economic sustainability by providing affordable heating to all residents. Vernacular architecture in mountainous regions. In mountainous regions, vernacular architecture uses sloping roofs, thick walls, and natural insulation to protect against cold temperatures and heavy snowfall. An example of this is the traditional chalets in the Swiss Alps, which use sloping roofs to shed snow and thick walls for insulation. Planned cities in coastal regions. In coastal regions, planned cities such as Vancouver, Canada, prioritize sustainable transportation options such as cycling and public transit to reduce carbon emissions and promote social sustainability. They also use green infrastructure such as rain gardens and bioswales to manage stormwater runoff and reduce the risk of flooding. These are just a few examples of sustainable architecture in human settlement planning and housing from different geoclimatic zones. By incorporating vernacular and traditional design strategies and technologies, as well as innovative sustainable design solutions, architects and planners can help create sustainable communities that are resilient and adaptable to their environment. Explain with examples from vernacular and planned cities in different geoclimatic zones. Sure, here are some examples of vernacular and planned cities in different geoclimatic zones. Hot and dry climate. Vernacular architecture. Traditional mud brick houses in the city of Yazd, Iran, which use thick walls, shaded courtyards, and wind towers to keep the interior cool. Planned city. Masdar City in Abu Dhabi, UAE, which uses passive cooling strategies such as shading, natural ventilation, and a green belt to create a microclimate that is 15 to 20 degrees cooler than the surrounding desert. Hot and humid climate. Vernacular architecture. Stilt houses in the Mekong Delta region of Vietnam, which are elevated to prevent flooding and use natural ventilation to keep the interior cool and dry. Planned city. Singapore, which uses green roofs, vertical gardens, and green walls to reduce heat island effect and promote natural cooling. Cold climate. Vernacular architecture. The igloos of the Inuit people in Canada and Greenland, which use natural insulation and a compact, circular design to trap heat. Planned city. Stockholm, Sweden, which uses district heating systems that provide heat to entire neighborhoods from a centralized source. Mountainous climate. Vernacular architecture. Traditional chalets in the Swiss Alps, which use sloping roofs to shed snow and thick walls for insulation. Planned city. Bhutan's capital city Thimphu, which is designed to be compact and walkable, reducing the need for vehicular transportation and minimizing carbon emissions. Coastal climate. Vernacular architecture. The stilt houses of the Maldives, which use elevated platforms to protect against rising sea levels and flooding. Plan City, Vancouver, Canada, which prioritizes sustainable transportation options such as cycling and public transit to reduce carbon emissions and promote social sustainability. These examples illustrate how both vernacular and planned cities across different geoclimatic zones incorporate sustainable design strategies to respond to their unique environmental conditions. By using local materials, passive design strategies, and innovative sustainable technologies, these cities are able to minimize their environmental impact and promote social and economic sustainability. Climatic response of vernacular architecture analytical studies including developing scientific evidence. Analytical studies have shown that vernacular architecture has a strong climatic response due to the use of traditional materials, construction techniques, and design strategies that are adapted to the local climate conditions. Here are a few examples. Traditional mud brick houses in hot and dry climates. Studies have shown that thick walls made of mud bricks and plaster can provide effective insulation against the heat. Shaded courtyards and wind towers are also used to create a cooling effect by drawing in cool air and exhausting hot air. Stilt houses in hot and humid climates, raised platforms, which are commonly used in stilt houses, protect against flooding and provide natural ventilation that helps to keep the interior cool and dry. The use of thatched roofs also helps to regulate temperature and humidity levels. Chalets in cold climates, sloping roofs are used to shed snow and prevent snow accumulation, while thick walls provide insulation against the cold. The use of small, compact designs also helps to conserve heat. Thatched houses in tropical climates. Thatched roofs are common in tropical climates because they provide effective insulation against both heat and rain. The thatch material is also renewable and locally available. Many of these traditional design strategies have been studied in detail by scientists and researchers who have developed scientific evidence supporting their effectiveness in responding to the local climate. For example, studies have shown that mud brick houses in hot and dry climates can reduce indoor temperatures by up to 10 degrees Celsius compared to outside temperatures. Similarly, studies have shown that stilt houses in hot and humid climates can reduce indoor temperatures by up to 6 degrees Celsius compared to outside temperatures. Overall, the climatic response of vernacular architecture has been studied extensively, and the scientific evidence supports the effectiveness of traditional design strategies in responding to the local climate conditions. Water management in buildings, water saving/demand management, water harvesting for recharge and use, reuse/recycling. Water management in buildings is an important aspect of sustainable architecture and includes strategies for water conservation, water harvesting, and water reuse. Here are some examples of water management strategies in buildings. Water-saving fixtures. Buildings can incorporate water-saving fixtures such as low-flow toilets, faucets, and shower heads that use less water without compromising performance. Demand management. Demand management strategies can be used to reduce water consumption in buildings. For example, building owners and managers can monitor water usage and identify areas where water is being wasted, then implement changes such as repairing leaks, reducing irrigation, and using efficient appliances. Water harvesting. Rainwater harvesting is a technique that captures rainwater from roofs and other surfaces and stores it for later use. This water can be used for irrigation, flushing toilets, and other non-potable uses, which can reduce the demand for municipal water and lower water bills. Greywater reuse. Greywater is wastewater from sinks, showers, and washing machines that can be treated and reused for non-potable purposes such as irrigation, toilet flushing, and laundry. This can help reduce the demand for fresh water and save money on water bills. Recycling wastewater. Some buildings use on-site wastewater treatment systems to recycle wastewater for reuse. This can include treating wastewater to a level suitable for drinking, potable reuse, which can help reduce the demand for municipal water and provide a reliable source of water. Overall, water management in buildings is an important aspect of sustainable architecture, and incorporating water-saving fixtures, demand management strategies, water harvesting, and water reuse can help reduce water consumption, lower water bills, and conserve water resources. Traditional architecture water management in buildings, water saving/demand management, water harvesting for recharge and use, reuse/recycling. Water management in traditional architecture also includes strategies for water conservation, water harvesting, and water reuse. Traditional buildings in different parts of the world have incorporated various techniques for managing water. Here are some examples. Water harvesting. In arid regions, traditional buildings have incorporated techniques for harvesting rainwater, such as collecting rainwater from roofs and storing it in underground tanks or cisterns. The water collected is used for irrigation, washing, and drinking. Aqueducts. Ancient civilizations such as the Romans and the Incas used aqueducts to transport water from distant sources to their cities. The water was then distributed to households through a system of channels and pipes. Wastewater reuse. In some traditional buildings, greywater from sinks, showers, and washing machines is collected and reused for irrigation, flushing toilets, and washing. Ponds and tanks. Traditional buildings in South Asia, such as stepwells and baolis, incorporated large ponds or tanks for storing rainwater. The water stored in these tanks was used for drinking, washing, and irrigation. Water-saving fixtures. Traditional buildings often incorporated water-saving fixtures such as low-flow taps and toilets, which helped conserve water. Overall, traditional architecture has incorporated a variety of techniques for water management, which can inspire modern buildings to incorporate similar strategies for water conservation and reuse. Explain with examples traditional architecture water management in buildings, water saving/demand management, water harvesting for recharge and use, reuse/recycling. Sure, here are some examples of water management techniques in traditional architecture. Water harvesting. Traditional buildings in arid regions have incorporated water harvesting techniques for capturing and storing rainwater. For example, in Rajasthan, India, the traditional architecture includes stepwells, bauris, that have a series of steps leading down to a pool of water. These stepwells were used to collect and store water during the monsoon season. Greywater reuse. Greywater is wastewater from sinks, showers, and washing machines that can be reused for non-potable purposes such as flushing toilets and watering plants. Traditional buildings in many parts of the world have incorporated greywater reuse systems. For example, in Morocco, the traditional architecture includes riads with central courtyards that have a small pool or fountain for collecting and reusing greywater. Water-saving fixtures. Traditional buildings often incorporate water-saving fixtures such as low-flow taps and toilets. For example, in Japan, the traditional architecture includes washlets, toilets with built-in bidets, that use a small amount of water for cleaning, thus reducing the amount of water needed for flushing. Aqueducts and irrigation systems. Traditional architecture in ancient civilizations such as the Romans and the Incas incorporated aqueducts and irrigation systems for transporting and distributing water. For example, in Peru, the ancient city of Machu Picchu had a sophisticated system of terraces and irrigation channels that allowed for agricultural production in the mountainous region. Ponds and tanks. Traditional buildings in South Asia, such as stepwells and baolis, incorporated large ponds or tanks for storing rainwater. The water stored in these tanks was used for drinking, washing, and irrigation. These examples show that traditional architecture has incorporated a variety of techniques for water management, which can inspire modern buildings to incorporate similar strategies for water conservation and reuse. Sustainability lessons from traditional architecture. Traditional architecture from various regions of the world offers valuable sustainability lessons that can inform modern architecture and urban planning. Some of the lessons that can be learned include: climate-responsive design. Traditional architecture has developed over centuries of experience and understanding of local climate conditions. Buildings were designed to respond to the local climate, using materials and design features that provide thermal comfort without relying on mechanical heating or cooling systems. For example, in hot and arid regions, buildings often had thick walls to provide insulation and small openings for ventilation to keep indoor temperatures cool. Use of local and natural materials. Traditional architecture relied heavily on local materials that were abundant and readily available. This not only reduced the environmental impact of transporting materials, but also helped to preserve local ecosystems. Natural materials such as wood, stone, and clay were used in construction, providing durability and longevity to the buildings. Water management. Many traditional buildings were designed to conserve and manage water resources. This was particularly important in regions with water scarcity, where water harvesting and recycling were common practices. For example, in India, traditional buildings often had rainwater harvesting systems to collect and store rainwater for later use. Community-based design. Traditional architecture often reflected the social and cultural values of the communities it served. Buildings were designed to facilitate social interaction and communal living, creating strong bonds between individuals and the community. This sense of community and connection to the environment is important for promoting sustainability in modern architecture and urban planning. Adaptive reuse. Traditional architecture often used adaptable design principles that allowed buildings to be repurposed or adapted for different uses over time. This approach promotes sustainable use of resources and reduces waste by extending the lifespan of buildings. For example, many old warehouses and factories in urban areas have been repurposed into housing or community spaces, preserving the historic architecture while meeting the changing needs of the community. In summary, traditional architecture provides a wealth of sustainable design principles that can inform modern architecture and urban planning. By learning from the wisdom of the past, we can create sustainable built environments that promote environmental, social, and economic sustainability. Scale and context of sustainability, issues, and solutions in the current world. The scale and context of sustainability vary depending on the area and the issues specific to that location. In the current world, there are numerous sustainability challenges that require solutions at various scales, including global scale. Climate change is one of the most significant sustainability challenges at a global scale. The rise in temperature due to increased greenhouse gas emissions is affecting the planet's ecosystems, causing sea levels to rise, and leading to natural disasters such as floods, hurricanes, and wildfires. National scale. Governments need to implement policies that address sustainability issues such as energy efficiency, renewable energy, waste management, and transportation. For example, many countries have introduced policies to reduce greenhouse gas emissions and increase the use of renewable energy. Regional scale. Sustainable development at the regional level involves planning for sustainable land use, transportation, and infrastructure. For instance, cities can develop smart growth policies that promote compact, mixed-use developments, and walkable neighborhoods, which can reduce car dependency and promote public transportation. Local scale. At the local level, building sustainable communities involves designing buildings and public spaces that are energy efficient, use renewable energy, promote water conservation, and encourage green spaces. For example, green roofs and walls can help absorb stormwater runoff, reduce heat island effects, and provide insulation. Solutions to these challenges include adopting sustainable building practices, such as using eco-friendly materials, reducing energy consumption, and designing for passive heating and cooling. Investing in renewable energy and energy-efficient technologies, such as solar panels, wind turbines, and efficient lighting systems. Promoting sustainable transportation, such as public transportation, biking, and walking. Encouraging sustainable land use, such as mixed-use developments, green infrastructure, and urban agriculture. Developing sustainable water management practices, such as rainwater harvesting, greywater recycling, and low-flow fixtures. Overall, sustainability requires a holistic approach that addresses environmental, social, and economic issues. By implementing sustainable practices and solutions, we can create a more resilient and equitable world for current and future generations. Relevance of traditional and vernacular architecture in finding sustainable solutions to present situations. Traditional and vernacular architecture can provide valuable insights and solutions to contemporary sustainability issues. These architectural forms have evolved over centuries in response to local climatic conditions, available resources, and cultural practices. They often incorporate sustainable principles such as passive cooling and heating, natural ventilation, use of local materials, and water management systems. By studying and understanding these principles, architects and designers can apply them in modern sustainable building design. For example, in hot and arid regions, traditional architecture often uses thick walls made of locally available materials such as mud or stone, which provide thermal mass to regulate indoor temperatures. In addition, buildings are often oriented to take advantage of prevailing winds for natural ventilation, and shading devices such as courtyards, balconies, and overhangs are used to reduce heat gain. These principles can be applied in modern building design to reduce energy consumption for cooling. Similarly, traditional water management systems such as rainwater harvesting, groundwater recharge, and greywater recycling can be used in modern buildings to reduce water consumption and waste. In addition, the use of natural and locally sourced materials can reduce the environmental impact of construction and promote sustainable building practices. In summary, traditional and vernacular architecture can provide a valuable resource for contemporary sustainable building design. By incorporating sustainable principles from traditional architecture, architects and designers can create buildings that are not only environmentally friendly, but also culturally appropriate and economically viable. Explain in detail relevance of traditional and vernacular architecture in finding sustainable solutions to present situations. Traditional and vernacular architecture can offer valuable insights and lessons in finding sustainable solutions to present-day problems. These architectural styles have evolved over centuries, and their design principles and techniques have been refined to respond to the local climate, culture, and available resources. One of the key advantages of traditional and vernacular architecture is their ability to work in harmony with nature. For example, traditional buildings in hot and arid regions use passive cooling techniques such as courtyards, wind towers, and thick walls to keep the interior cool. Similarly, vernacular buildings in cold regions use passive heating techniques such as solar orientation, thick walls, and insulation to retain heat and reduce energy consumption. In addition to their sustainable design, traditional and vernacular buildings also have a close relationship with their surrounding environment. They often use locally sourced materials, which reduces the carbon footprint associated with transportation and manufacturing. Furthermore, they are designed to blend in with the local landscape and are often built with an understanding of the natural rhythms of the surrounding ecosystem. Traditional and vernacular architecture can also offer solutions to current issues such as urbanization and housing shortages. For example, the courtyard houses found in many traditional settlements can offer a template for compact, high-density living that is both comfortable and sustainable. Similarly, vernacular architecture in rural areas often employs techniques such as earth construction and thatched roofs, which can be adapted to provide affordable and sustainable housing solutions. In summary, the relevance of traditional and vernacular architecture lies in their ability to offer sustainable solutions that are rooted in the local context. By learning from these architectural styles, we can develop more sustainable buildings and cities that are better suited to their environment and the needs of their inhabitants. Importance of application of principles of traditional and vernacular architecture in modern context to achieve sustainability in various aspects in urban design. The principles of traditional and vernacular architecture can play a significant role in achieving sustainability in modern urban design. Here are some of the ways in which traditional architecture can be applied to achieve sustainability. Passive design. Traditional buildings were designed to respond to local climate and environmental conditions. They relied on passive design strategies such as natural ventilation, shading, and thermal mass to maintain comfortable indoor conditions. The application of these strategies in modern buildings can reduce the need for energy-intensive mechanical systems and lower energy consumption. Use of natural materials. Traditional buildings were constructed using locally available natural materials such as adobe, timber, thatch, and stone. These materials have low embodied energy and are renewable, biodegradable, and non-toxic. Using natural materials in modern buildings can reduce the environmental impact of construction and improve indoor air quality. Adaptation to local context. Traditional buildings were adapted to the local context, taking into consideration factors such as topography, hydrology, and biodiversity. Incorporating these factors in modern urban design can help reduce the impact of development on the natural environment and promote ecological resilience. Community engagement. Traditional architecture often involved the active participation of local communities in the design and construction process. This approach fosters a sense of ownership and responsibility towards the built environment and can promote sustainable practices such as waste reduction, water conservation, and the use of renewable energy sources. Cultural significance. Traditional architecture is often closely linked to local culture and heritage. Incorporating traditional architectural elements in modern buildings can not only promote cultural continuity, but also provide a sense of identity and placemaking. In summary, the application of principles of traditional and vernacular architecture in modern urban design can promote sustainability in various aspects such as energy efficiency, use of natural materials, adaptation to local context, community engagement, and cultural significance. Importance of application of principles of traditional and vernacular architecture in modern context to achieve sustainability in various aspects. Urban built space ratio. The application of principles of traditional and vernacular architecture in the modern context is important to achieve sustainability in various aspects of urban design, including the urban built space ratio. The urban built space ratio refers to the ratio of built-up area to the total area of a site. It is an important factor in determining the sustainability of a building or a neighborhood. Traditional and vernacular architecture often have a lower urban built space ratio as compared to modern buildings, which tend to have a higher ratio due to the use of high-rise structures and increased floor area. The traditional and vernacular architecture makes efficient use of space and resources by employing compact and functional design solutions. The design of the buildings is often based on the principles of climatic responsiveness, which ensures that the buildings are well adapted to the local climate and environment. This reduces the energy consumption required for heating and cooling, and promotes natural ventilation and lighting. The use of traditional building materials and construction techniques is also important in achieving sustainability in the urban built space ratio. Traditional materials such as mud, bamboo, and timber are renewable and locally available, which reduces the carbon footprint associated with transportation and manufacturing. Additionally, these materials are often used in a way that minimizes waste and maximizes the lifespan of the building. Incorporating the principles of traditional and vernacular architecture in the design of modern buildings and neighborhoods can lead to a lower urban built space ratio and a more sustainable urban environment. This can help to reduce the impact of urbanization on the environment and promote sustainable development for future generations. Elaborate in detail importance of application of principles of traditional and vernacular architecture in modern context to achieve sustainability in various aspects. The application of principles of traditional and vernacular architecture in the modern context can play a crucial role in achieving sustainability in various aspects of urban design. Here are some of the ways in which traditional and vernacular architecture can contribute to sustainable urban design. Climate responsiveness. Traditional and vernacular architecture often exhibit a deep understanding of the local climate and environmental conditions, resulting in buildings that respond to their surroundings in a way that maximizes comfort while minimizing energy use. For example, thick walls, high ceilings, and open courtyards in traditional buildings in hot and arid regions promote natural ventilation and passive cooling, reducing the need for mechanical cooling systems. Use of local materials. Traditional and vernacular architecture typically relies on locally available materials, which are often more sustainable and have a lower environmental impact than materials transported from afar. Using local materials also supports local economies and can reduce carbon emissions associated with transportation. Community participation. Traditional and vernacular architecture often involves the participation of the local community in the design and construction process, resulting in buildings that reflect local cultural values and are more likely to be valued and maintained over time. Community participation can also promote social sustainability by fostering a sense of community ownership and responsibility. Water management. Many traditional and vernacular architecture practices incorporate water management techniques, such as rainwater harvesting, greywater recycling, and the use of permeable surfaces to promote groundwater recharge. These practices can help reduce water consumption and mitigate the impacts of urbanization on local water resources. Adaptive reuse. Traditional and vernacular buildings often have a high degree of adaptability, allowing them to be repurposed for new uses without significant alterations. Adaptive reuse of existing buildings can reduce the environmental impact of new construction and preserve cultural heritage. Biophilic design. Traditional and vernacular architecture often incorporates biophilic design elements, such as the use of natural materials, vegetation, and water features. Biophilic design has been shown to have positive impacts on human health and well-being, including reduced stress, improved cognitive function, and increased creativity. Overall, the application of principles of traditional and vernacular architecture in modern urban design can contribute to a more sustainable and resilient built environment, one that is responsive to local environmental conditions, supports local economies and communities, and promotes human well-being. Importance of application of principles of traditional and vernacular architecture in modern context to achieve sustainability in various aspects. Urban built space ratios explain in detail. Urban built space ratio is an important aspect of urban design and sustainable development. It refers to the proportion of built-up area in relation to the total area of a site or a city. The built-up area includes all buildings, roads, parking lots, and other physical infrastructure, while the total area includes all green spaces, water bodies, and other natural features. Traditional and vernacular architecture often incorporates principles of sustainable design that promote a balanced relationship between built-up areas and natural surroundings. For example, many traditional buildings in India are designed with courtyards that allow for natural ventilation and lighting, as well as green spaces that provide shade and mitigate heat island effects. These buildings often have a lower built space ratio, allowing for more open space and natural features within the built environment. In modern urban design, the application of such principles can help to create more sustainable and livable cities. A lower built space ratio can help to reduce the heat island effect, improve air quality, and promote a more natural and pleasant living environment. It can also help to conserve natural resources by reducing the amount of land that is paved over or used for building construction. In addition, a lower built space ratio can provide more opportunities for green spaces and public parks, which can promote physical activity, social interaction, and mental well-being. Such spaces can also serve as important ecological corridors, providing habitats for native species and improving biodiversity within urban areas. Overall, the application of principles of traditional and vernacular architecture in modern urban design can help to create more sustainable and livable cities by promoting a balanced relationship between built-up areas and natural surroundings, and by providing more opportunities for green spaces and public parks. Urban Built Space Ratio. Explain in detail. Urban Built Space Ratio, UBSR, is a measure of the density of buildings and structures within an urban area. It is a key factor that impacts the overall sustainability of an urban environment, as it determines the amount of land used for buildings, transportation, and other urban infrastructure. UBSR is typically expressed as the ratio of the total built area to the total area of the land on which it is built. This includes both residential and commercial buildings, as well as infrastructure such as roads, bridges, and other public works. A higher UBSR indicates a more compact urban area, while a lower UBSR indicates a more spread out or suburban environment. The UBSR has important implications for sustainability. A high UBSR can help to reduce the amount of land used for urban development, preserving natural habitats and ecosystems. It can also support more efficient use of resources such as water and energy, as buildings can be designed to take advantage of shared infrastructure and services. However, a high UBSR can also lead to congestion and other negative impacts on quality of life, including increased air pollution, noise, and traffic. It can also lead to higher demand for resources such as water and energy, which may need to be imported from elsewhere. Balancing the benefits and challenges of different UBSRs is a key consideration in urban planning and design. Some approaches to achieving a more sustainable UBSR include promoting transit-oriented development, encouraging mixed-use development, and investing in green infrastructure such as parks and open spaces. Importance of application of principles of traditional and vernacular architecture in modern context to achieve sustainability in urban street canyons. Traditional and vernacular architecture can provide valuable insights and solutions for achieving sustainability in urban street canyons. Street canyons refer to the narrow spaces between buildings in urban areas, where buildings can significantly impact the microclimate and air quality. Traditional and vernacular architecture in different parts of the world has demonstrated strategies for mitigating the negative impacts of urban street canyons. For example, in hot and arid regions, traditional buildings often have narrow streets and high walls to provide shade and reduce the amount of direct sunlight on the ground. In addition, wind towers or chimneys are used to create natural ventilation and cooling inside buildings. Similarly, in tropical regions, buildings often have wide overhanging eaves to provide shade and reduce the amount of direct sunlight on walls and windows, and open courtyards or atriums are used to promote natural ventilation and cooling. In modern urban design, applying these traditional principles can help reduce the need for energy-intensive air conditioning and ventilation systems, leading to more sustainable and energy-efficient buildings. For example, designing buildings with narrower facades and taller heights can increase natural ventilation and reduce the heat island effect. Incorporating green roofs and walls can also help reduce heat absorption and improve air quality. Furthermore, designing streets and public spaces with consideration for pedestrian and cyclist safety and accessibility can encourage alternative modes of transportation, such as walking or biking, leading to a reduction in greenhouse gas emissions from transportation. Overall, the application of traditional and vernacular architecture principles in modern urban design can provide sustainable solutions to the challenges posed by urban street canyons, leading to more livable and environmentally friendly cities. Importance of application of principles of traditional and vernacular architecture in modern context to achieve sustainability in various aspects: urban built space ratios, urban street canyons, environmental design and cultural identity, etc. The application of traditional and vernacular architecture principles in the modern context can play a significant role in achieving sustainability in various aspects of urban design, including urban built space ratios, street canyons, environmental design, and cultural identity. Urban built space ratios. Traditional and vernacular architecture often prioritized the efficient use of space and resources, resulting in compact and functional urban designs. These designs utilized a higher urban built space ratio, which refers to the ratio of built-up area to the total land area. High urban built space ratios lead to compact cities, reducing the need for extensive infrastructure and transportation networks, thereby reducing energy consumption and greenhouse gas emissions. Urban street canyons. Traditional and vernacular architecture designs often prioritized the comfort and livability of urban street canyons, which are the spaces between buildings that form streets. These designs employed various techniques such as building orientation, shading devices, and the use of natural ventilation to mitigate the adverse effects of heat islands, reduce energy consumption for cooling, and improve the comfort of pedestrians. Environmental design. Traditional and vernacular architecture designs often prioritized environmental design, such as passive solar heating, natural ventilation, and rainwater harvesting. These designs utilized materials that were locally available and could be sustainably sourced, reducing the carbon footprint of construction and minimizing waste. By incorporating these principles into modern architectural designs, the environmental impact of buildings can be significantly reduced. Cultural identity. Traditional and vernacular architecture designs reflect the cultural identity and heritage of the communities they serve. Incorporating these designs into modern architecture can help preserve cultural heritage and identity while also promoting sustainable development. In conclusion, the application of traditional and vernacular architecture principles in modern urban design can help achieve sustainability in various aspects, including urban built space ratios, urban street canyons, environmental design, and cultural identity. These principles can help create livable, sustainable, and culturally significant cities for future generations. Importance of application of principles of traditional and vernacular architecture in modern context to achieve sustainability in environmental design and cultural identity. Explain in detail with examples. Environmental design and cultural identity are important aspects of sustainable architecture that can be achieved by incorporating the principles of traditional and vernacular architecture in modern contexts. Traditional and vernacular architecture often considers the local climate, materials, and culture of the region, creating buildings and urban spaces that are sustainable and deeply connected to the local context. For example, in hot and arid regions, buildings are often designed with thick walls and small windows to provide shade and natural cooling. In regions with heavy rainfall, buildings may be raised on stilts or built with sloping roofs to protect against flooding. Incorporating these principles into modern architecture can help to create buildings and urban spaces that are more sustainable and responsive to local environmental conditions. This can include the use of locally sourced materials, passive cooling and heating strategies, and the preservation of existing ecosystems and natural features. At the same time, incorporating traditional and vernacular architecture into modern designs can also help to preserve cultural identity and heritage. By creating buildings and urban spaces that reflect the local culture and history, modern architecture can contribute to a sense of place and community identity. One example of this is the incorporation of traditional courtyard houses into modern designs in the Middle East. These houses are designed around a central courtyard, providing natural ventilation and a cool, shaded outdoor space. By incorporating these elements into modern designs, architects can create buildings that are both sustainable and reflective of local cultural traditions. Another example is the use of adobe construction in modern buildings in the southwestern United States. Adobe is a traditional building material made from earth and other natural materials, and it provides excellent thermal insulation, helping to keep buildings cool in hot desert climates. By using adobe in modern buildings, architects can create structures that are sustainable, energy efficient, and connected to the local cultural heritage. Overall, the application of principles of traditional and vernacular architecture in modern contexts can play an important role in achieving sustainability in environmental design and preserving cultural identity. By creating buildings and urban spaces that are responsive to local environmental conditions and reflect local cultural traditions, architects can help to create more sustainable and livable communities. Importance of application of principles of traditional and vernacular architecture in modern context to achieve sustainability in environmental design and cultural identity. The application of principles of traditional and vernacular architecture in modern context is crucial to achieve sustainability in environmental design and cultural identity. Traditional and vernacular architecture has evolved over centuries, responding to the local climatic, cultural, and environmental conditions. The sustainable features of traditional and vernacular architecture can be incorporated into modern architecture to achieve energy efficiency, climate responsiveness, and cultural identity. Environmental design. Traditional and vernacular architecture often respond to the local environment by utilizing materials and design strategies that enhance energy efficiency and comfort. For example, in hot and arid regions, buildings often incorporate thick walls, courtyards, and shading devices to protect from the harsh sun and provide passive cooling. Similarly, in cold regions, buildings often incorporate thick insulation and south-facing windows to maximize solar gain and provide passive heating. By incorporating these design strategies, modern architecture can reduce energy consumption and increase thermal comfort for occupants. Cultural identity. Traditional and vernacular architecture also reflects the cultural identity of a place. Architecture is a powerful tool to communicate the history, traditions, and values of a community. By incorporating vernacular design elements and materials, modern architecture can celebrate local identity and contribute to the sense of place. For example, the use of traditional materials such as timber, adobe, or thatch can create a sense of continuity with the past and reflect the local culture. Examples. One example of the incorporation of vernacular architecture in modern design is the Sanobe House in Japan. The house is designed to respond to the local climate, using passive cooling strategies such as shading devices, natural ventilation, and thermal mass. The design incorporates traditional materials such as timber and clay, creating a connection with the local culture. Another example is the Muskum mud houses in Cameroon. The houses are built with mud bricks and incorporate a central courtyard to provide passive cooling and social interaction. The design of the houses reflects the cultural identity of the Muskum people and has been adapted over centuries to respond to the local climate. In conclusion, the application of principles of traditional and vernacular architecture in modern context is crucial to achieve sustainability in environmental design and cultural identity. By incorporating vernacular design elements and responding to local climate and culture, modern architecture can create buildings that are energy efficient, climate responsive, and culturally meaningful. Sustainability lessons from traditional architecture. Case studies of contemporary examples inspired from the past. There are several contemporary examples of architecture that have been inspired by traditional and vernacular principles, demonstrating the potential of these practices to inform sustainable design. Here are a few case studies. The Sheikh Zayed Desert Learning Center, UAE. This project was designed to be an educational facility for the conservation of the UAE's desert environment. The center is designed to incorporate traditional building techniques and materials, such as adobe walls, and utilizes passive cooling strategies to reduce energy consumption. The design also incorporates a variety of sustainable features, such as rainwater harvesting, gray water recycling, and renewable energy sources. The Green School, Bali. The Green School is a private school that was founded with a focus on sustainability education. The school is constructed primarily from bamboo, a traditional building material in Bali, and incorporates sustainable technologies such as rainwater harvesting and solar panels. The buildings are designed to be naturally ventilated, and the site is landscaped with edible gardens and permaculture techniques. The New Gourna Village, Egypt. The New Gourna Village was designed in the 1940s by architect Hassan Fathi as a sustainable community to replace the historic village of Gourna, which was threatened by archaeological excavation. The village is constructed from traditional mud brick and incorporates passive cooling strategies, such as courtyards and wind catchers. The design also includes a central market square and communal facilities to encourage social cohesion. The Kajalo School, Kenya. The Kajalo School was designed by architect David Ajay with a focus on sustainability and community engagement. The school is constructed primarily from locally sourced materials, such as brick and timber, and incorporates passive cooling strategies and renewable energy sources. The design also includes community spaces, such as a library and outdoor gathering areas, to encourage social interaction and collaboration. These examples demonstrate the potential for traditional and vernacular architecture to inform contemporary sustainable design and highlight the importance of understanding the cultural and environmental context of a project. By incorporating these principles and practices, architects and designers can create buildings and communities that are environmentally responsible, socially equitable, and culturally relevant. Sustainability lessons from traditional architecture. Case studies of contemporary examples in India inspired from the past. There are several contemporary examples in India where architects and designers have drawn inspiration from traditional and vernacular architecture to create sustainable buildings and spaces. Here are a few case studies. IIM Ahmedabad, Indian Institute of Management, Ahmedabad. The IIM Ahmedabad campus is an example of modern architecture inspired by traditional elements. The campus was designed by architect Louis Kahn in the 1960s and features exposed brickwork, shaded courtyards, and natural ventilation, all of which draw on traditional Indian architectural principles. Auroville, Tamil Nadu. Auroville, located in Tamil Nadu, is an experimental town founded in 1968 that aims to promote sustainability and communal living. The town features a range of sustainable buildings, including the Matrimandir, a golden dome that functions as a meditation center and uses passive solar design principles to minimize energy use. Indira Pariyavaran Bhawan, New Delhi. The Indira Pariyavaran Bhawan in New Delhi is a government building designed to be energy efficient and environmentally sustainable. The building features a range of sustainable design features, including a green roof, rainwater harvesting, and solar panels. The design draws on traditional Indian architectural principles, such as the use of courtyards, to provide natural ventilation and light. Chikmagalur Earth House, Karnataka. The Chikmagalur Earth House in Karnataka is a private residence designed to be eco-friendly and sustainable. The house is constructed entirely from locally sourced materials, including mud, stone, and wood. The design incorporates traditional Indian architectural elements, such as a central courtyard for natural ventilation and light. Ahana Resort, Uttarakhand. The Ahana Resort in Uttarakhand is an eco-friendly resort that draws on traditional Indian architectural principles to minimize its environmental impact. The resort features mud-plastered walls, thatched roofs, and open spaces to provide natural ventilation and light. The design incorporates traditional elements, such as a central courtyard and water features. These examples show that traditional and vernacular architecture can provide inspiration for sustainable design in contemporary buildings and spaces. By drawing on the principles of natural ventilation, passive solar design, and the use of local materials, architects and designers can create buildings and spaces that are both environmentally sustainable and culturally relevant.